Hello, I'm Declan Cannon. Welcome to the Weather Channel's Western Extremes. In this Weather Extra, we explore the different and sometimes unusual weather conditions that affect the western U.S. We begin with a look at two very common but often dangerous conditions: fog and smog. It can be both beautiful and terrifying. Fog plays a part in everyone's lives. Radiation, or valley fog, is common in California, and it usually forms at night. The air near the ground becomes gradually cooler until the dew point is reached and a layer of water vapor is condensed into water droplets of fog like a cloud. More fog forms as the night continues. The mountain ranges surrounding the Central Valley help to hold it in place. Radiation fog begins to lift and thin as the daylight hours progress, when the warming rays of the sun heat up the atmosphere, which then absorbs the moisture. But before the fog drifts away, the potential for danger is high. Every year, hundreds of accidents are caused by the phenomenon. Special warning signs have been installed, but it simply comes down to the caution of the driver. Another problem inherent with the western part of the country, and especially Los Angeles, is smog, which is basically air that is contaminated by pollution from factories and auto exhaust. The heavily populated and industrial city of Los Angeles is situated in a basin with hills on three sides. Pollutants spewed into the air are trapped by the hills and the lid of warm air over the area, known as a temperature inversion. In addition, the afternoon sea breeze from the Pacific Ocean pushes the air against the mountains and concentrates the smog in inland valleys. It cannot escape until a strong wind clears it out, or the inversion disappears and allows the murky air to rise. The health problems are at times severe, even for children.
When it's a smoggy day, I have to stay in the house because I'll end up having to go into the hospital.
The good news is air quality in the western region of the United States has improved. Despite an increase in auto travel of almost 50% over the past decade, air pollutant levels have decreased overall by about 1/3. In turn, pollution restrictions on businesses have recently relaxed. Residents accept this man-made hazard as a way of life. In the case of fog, the line between beauty and danger is as thin as a cloud. While thunderstorms occur more frequently and with more intensity in the central and eastern states, they are not uncommon in the west. In fact, some elements of the western thunderstorm are unique. The weather of the western U.S. is every bit as amazing and diverse as the region's landscapes. Thunderstorms are among the West's many weather whims. Tornadoes, hail, high winds, and downpours have struck every state of the West.
The rain was hitting my door, and then it started hitting my window, and it started hitting my door, and it started hitting my window. And I said, "Mom, it's a tornado," you know. And she said, "No, it's not." I said, "Yes, it is." I jumped.
March 1st, 1983, a tornado cut a 3-mile swath of destruction through downtown Los Angeles, damaging more than 100 homes and businesses and injuring 33 people. Tornadoes like this are rare in the West. They are normally weak and appear as a stubby funnel protruding from a cloud. In California, winter to early spring is known as prime thunderstorm season. The vigorous storms sweep in off the Pacific Ocean. Cold air aloft creates instability. Heavy rains can occur ahead of the front, but different from typical severe thunderstorms in the central and eastern states, most of the activity occurs after the cold front passes through. Heavy rain, swift-moving streets of water, and localized flooding are common scenes across the southwestern U.S. during the summer. The phenomena that produces these conditions is known as a monsoon. The summer monsoon occurs when there is a ridge of high pressure over the U.S. Winds flowing around the backside of that ridge bring moisture up from the Gulf of Mexico and the Pacific Ocean into the southwest. In the Intermountain West, thunderstorms can pop up even when the atmosphere is dry. Dry thunderstorms sometimes produce winds strong enough to topple grounded airplanes and flip trucks off the road. These winds, known as downbursts, begin with falling rain showers. As the airflow drops below the cloud, the rain evaporates. Cooled by the evaporation, the downdraft of air becomes heavier and falls faster. It can hit the ground with winds over 100 miles an hour. Lightning is another damaging element of the West's dry thunderstorm. The dramatic bolts of electricity contribute to thousands of damaging forest fires each year. Even though one single spark can threaten a forest, the weather conditions in the West contribute greatly to the region's burning season. The storms of spring, bringing the rain necessary for California's hillside vegetation. Amid the green vegetation of a new season, people gather in Colorado to pay tribute. Here in Glenwood Springs, they honor the firefighters who battled a blaze on Storm King Mountain in 1994. And they remember those who died in that raging inferno. The tragedy in Colorado was the single worst event in one of the deadliest and most intense fire seasons in history in the West. Fires burned across the region, an annual rite, part of a natural cycle of cleansing and rebirth. But man has interfered with this cycle, and in his attempt to control his fate, has often endangered it. Nowhere is this more evident than on the hillsides of California. These hillsides are covered with a variety of plant life collectively referred to as chaparral, and they are a prime contributor to the fire cycle.
These are very volatile plants, very high terpene levels, and they burn very, very hot. Fire is a part of those ecosystems, those plant and animal species that evolved under frequent recurring fire. They need fire in order to perpetuate.
The fuel provided by the chaparral is only one element combining to set these hillsides ablaze. Another is the weather. In the spring, the jet stream begins to lift north while high pressure strengthens in the Pacific. That high is the dominant weather feature through the summer and into the fall, providing stable weather conditions over much of California. This stable pattern combines with the heat of summer to slowly rob the vegetation of its moisture. These conditions mean disaster lies but a spark away. Disaster that may be borne by the wind.
Santa Ana is a gusty, dry, sometimes dusty northeast wind. In a Santa Ana situation, the temperatures are warm, the humidity is very low, low enough that it draws the moisture out of the vegetation very, very quickly. So in that type of situation with the gusty winds, all it takes is a spark to turn into a very large fire very quickly.
Though not a Santa Ana, it was the wind that fanned a smoldering campfire in Marin County, north of San Francisco, into a raging wildfire in early October '95. The blaze roared through tinder-dry brush and pines, burning 12,000 acres and engulfing 40 homes. Western residents wait for the winter rains to come and soothe the parched land. But all too often, the rains of winter bring much more than expected. In parts of the West, the earth lies parched and often scorched, following the blazing summer of the fire season. It eagerly awaits the soothing moisture brought by winter's rains, looking forward to the rebirth promised by the approaching storm clouds. Sometimes, though, the clouds bring more than the land can handle. Such was the case in the winter of '94-'95. As the season began, long-term drought was well established in the region, but near normal precipitation between October and December helped alleviate the situation. Then, as January ushered in 1995, dreams of a prosperous new year quickly vanished for many in the West, especially in California. Rain began falling on New Year's Day and continued throughout the month. Records fell as the rainfall totals mounted. In northern parts of the state, rivers breached their banks as they crested at near record levels. Meanwhile, to the south, flash flooding and mudslides swept down hillsides, overtaking homes and roadways. The raging waters threatened to engulf all that stood in their path. By the end of the month, 36 counties in California had been declared federal disaster areas. Rainfall totals reached over 30 inches for the month in some areas, and the LA airport reported its wettest month on record with more than a foot of rain. Still dazed by the fury of nature's wrath, residents set themselves to the task of reclaiming their lives. But they were in for another setback.
We're getting high winds here. We've estimated them to be 40 to 50 miles per hour, and then it's raining really hard at this point.
During the first 2 weeks of March, a series of storms slammed into California. Wind gusts over 100 miles an hour were reported along the coast. Heavy rain once again forced rivers over their banks and sent flows of mud and debris rushing down hillsides. The onslaught forced thousands from their homes. Travel in the state was disrupted. Power was lost to more than 1 million people. As it had done in the fire season, nature reclaimed the land from those who inhabit it. The same rains that cause catastrophe in the valleys often bring snow to the mountains. This snow plays a necessary role in the lives of many Westerners. It's one of the pleasures of winter and provides an important benefit to the city of Los Angeles.
Los Angeles lies on an arid coastal strip of California, and it receives virtually no rain during the entire summer season. And so for Los Angeles to exist, it needs a good source of water, and we have that through the Sierra Nevada snowmelt.
In spring, the snowmelt pays off by providing water to the more than 3 million residents of Los Angeles. The melted snow gets there by way of an aqueduct system. Water travels through 338 miles of pipeline, conduit, and tunnel from Lee Vining in the Mono Basin area, through Owens Valley, the Mojave Desert, to Sylmar in the San Fernando Valley. Before the melt, the snowpack is monitored as it accumulates in the mountains through the winter. This graph shows how the Los Angeles Department of Water and Power analyzes the data. They track the snowfall throughout the year. As an example, let's compare the wettest year on record, 1982 to 83, to the driest, 1976 to 77. As you can see, there can be quite a difference from year to year. 1994 to 95 was an extremely good year, approaching the record.
The different snowpack levels greatly affect the water supply to the city of Los Angeles. Los Angeles is intimately connected to the snowpack, and its survival, in fact, depends on it.
A typical storm might drop 2 feet of snow on the Sierra. When that 2 feet of snow melts in the spring and summer, it is going to produce about 72,000 acre-feet of water. That's enough water to supply the demand for about 500,000 LA residents for a year from 2 feet of snow. The water then goes through filtration in Los Angeles and is chlorinated. The combination of the snow in the Sierra and the marvel of engineering that brings the water to LA together make up the lifeblood of America's second largest city.